Okay. Good afternoon. Welcome to today's second lecture. So once again, I'm Mr. William. I'm taking you in this short course, which is the introduction to operating systems. Okay. So let us also not forget the motto for our instruction: pray and hard work to find success. So let us always make sure that we remember God in everything that we are doing, and that we put Him first in everything for us to be able to succeed. Okay, now let's dig in. So let's do the continuation of where we ended last time. Okay, so if you remember clearly, last time we talked about the different types of operating systems. We said we've got single program systems, simple batch, multi-access, and time sharing systems. We also talked about the advantages and also the importance of these different types of operating systems. We also gave examples of the operating systems. Okay, so here I just added just a few types of examples under operating system, so that it acts as a recap of the previous lessons, so that you don't forget where you are coming from. Okay, also what you call real-time systems. So now if you look at this diagram which is here, just in types of operating systems. So you've seen here this person is looking at a cartoon, is holding a laptop, and then these are the different types of operating systems. So the first one we've got the bash operating system, time sharing, distributed network, real-time operating systems. Okay, let's move on to the next slide, which is basically talking about the application. So like I mentioned earlier on, when we just started the introductory to this course, so I said under the operating system we've got two categories of softwares. The first one is the system software, then the second one is the application software. So under the system software, we'll be able to look at the advantages and also their characteristics, the system software and also the application software. Then later on, that's when we'll now talk about the differences between the two. Okay, so now when we talk of the application software, by definition we're saying it is a set of computer instructions written in a programming language. Okay, so now one will be able to do a programming language and demonstrations. We're going to demonstrate the skills that are needed in programming language and way programming. Okay, so now here on the left hand side, if you look, we've got different types. We've got Microsoft Word, we've got Gmail, Google Docs, Google Drive, the YouTube. Yeah, I'm sure you can see the icons which are showing in this screen. So if we talk of the application software, we're simply talking about the applications or the application softwares that are used to perform specific tasks. Like for example, this Microsoft Word here, we cannot use it to play video or music, but it is meant specifically for documents like typing, editing, and also doing the designing. Okay, so we got also here the Gmail. This one Gmail here. Okay, so the Gmail, it has got its specific functions. We use it specifically for communication purposes. Then there's also YouTube. YouTube, as you all know, is basically for videos, so that's its function. It was specifically programmed for that. Okay, let's make progress. So the instructions direct computer hardware to perform specific data or information processing activities that provide functionality to the user. So now here on the second point, the instructions that we are talking about, it is the commands you as a user, when you're operating a computer, you give to the computer and it obeys. So it's also obeying and also it gives you the feedback according to the commands, according to the given instructions. Okay, let's move on now to the third point, which is saying this functionality may be broad, such as organizations, payroll program. Fourth one, we are saying an application program applies a computer to a need, such as increasing productivity of accountants to improve decisions regarding an inventory label. Application programming is either the creation or the modification and improvement of application software. So remember, these icons which are showing me are some of the examples of the application software. From this simple definition, you can be able to conclude that application software depends on system software, but system software doesn't depend on this one, the application software for it to run. So you'll be able to understand the meaning of that statement as we dig into details. Okay, so an example, so we go now to system software. So now an example of system software would be the Windows operating system. So using the system software Windows, you can operate an application software such as the Microsoft Word, like I mentioned earlier on. So now you'll see that an operating system doesn't depend on the application system software for it to work, but application softwares, they depend on the system software for them to be able to work. Okay, so under the same system software, we are saying is a type of program that is designed to run a computer's hardware and application programs. If we think of the computer system as a layered model, the system software is the interface between the hardware and user applications. So talking about the word interface, we'll be able to also in this same lecture look at the different types of the user interfaces that we have, and also their advantages and disadvantages of the different types of user interfaces that we have. Okay, so now we move on. The operating system is the best known example of the system software. So system software is a type of software that is designed to provide a platform for running and operating other software meaning in this case we are now referring to application softwares. Microsoft Word, VLC, or the software that are meant to programmed to perform specific tasks. Okay, so you need system software to run an application software. So this basically shows that okay, it entirely depends on the system software for it to be able to run, for the user to be able to use it. Okay, we move on. So the first, I will go over some system software examples, and some of these system software examples are very well known, with while others might be less well known. Okay, so the first one is the Windows operating system. Like we mentioned earlier on, the Windows operating system is one example under the system softwares. So now the Windows operating system. Under Windows operating system, this is where we find operating systems like Windows 7, Windows 8, Vista, Windows XP. So it started with the first generation, we are now in 5th generation. Okay, so now this time there is even Windows 11. So they keep on improving, keep on updating Windows, different types of Windows. Okay, so now the Windows operating system is perhaps one of the most well-known system softwares. Many laptops and desktops use the Windows OS. Okay, so using the Windows operating system, mostly abbreviated as the OS, you can install various application software like Microsoft Word, Google Chrome, Firefox, and many other applications that I'm sure you are now familiar with. So the vast majority of computers, they run on Windows, with more than 75% and up to 87% of computers using Windows. Okay, so now since Windows interacts closely with your device's hardware, to run applications on it, it is the system software. So if you don't have Windows, you can also use macOS or another system software installed. You won't be able to do anything on your computer, let alone learn application software. So you see now the importance of this system software. It is the one responsible for the coordination of the software and also the hardware part. The hardware part, like for example, we cannot plug in or put in connect the keyboard. It can't work minus having the system software installed on the computer. Okay, so now the second closest operating system is the Mac, which is popular but only makes up a smaller percentage of the market share. Okay, so these were some of the examples of system softwares. So now, having talked about the system softwares and also the application software, so by now you should be able to differentiate between application softwares and system softwares, and also be able to give examples, especially where necessary. Okay, so one of the major difference that I keep on repeating is saying application softwares, these are softwares programs that depend on the system software for them to run, but the system software doesn't depend on the application software for it to run. Okay, should take note of that. Okay, now let's go to programming language. So programming language, by definition, we are saying these are the basic building blocks for all systems and application software. Okay, so now to make all these softwares, they have been programmed using what we call the same programming language here. Okay, so programming languages are basically a set of symbols and rules used to write program code. So each language uses a different set of rules and the syntax that dictates how the symbols are arranged so they have meaning. The characteristics of the languages depend on their purpose. Languages also differ according to when they were developed. Today's languages are more sophisticated than those written in the 1950s and the 1960s. I'm sure by then you are not even there. Alright, so now let us also look at the levels of programming languages. So programs written for a computer may be in one of the following categories of languages. The first one, machine language. So machine language, we'll be able to look at the machine language in detail after this slide, but just so that you should know the definition of a machine language, this is the language that the computer understands. So the computer only understands the zeros and ones, which we call the binary digits. There's also an assembly language. We want to look at that one. High level language, this is basically the normal English, the language that us users or human beings are able to understand. Okay, let's move to details. So the machine language. So machine language, this is a sequence of instructions written in form of binary numbers consisting of ones and zeros, to which the computer responds directly. So now, especially for example, when you are typing the information you're using this keyboard, the computer doesn't necessarily understand the language that us humans were able to understand, but it translates the high level language into its language, which is called the machine language. Basically the zeros and ones Okay, so computer hardware recognizes only this type of instruction code. The advantage is that it's fast since the computer executes it directly. Now again, the disadvantage part is that it's difficult to understand and develop a program using machine language. Okay, so move on to assembly language. So now before we move on to assembly language, under the same machine language, we are talking about binary numbers. So in the binary numbers, we'll be able to do some like conversion from characters. So by characters, I mean, for example, the letters. We'll be able to convert now the letters into the language that the computer is able to understand, which is the machine language. Okay, so now there's also the coding scheme that you're supposed to be using, or that is supposed to be followed when doing that, which is why there it's online, but we'll be able to do some conversion, which is the ask code timetable. Okay, let's move on now to assembly language. When we employ symbols, letters, digits, or special characters. So for the operation part, the address part, and other parts of the instruction code, this representation is called an assembly language. Okay, so machine and assembly language are referred to as low-level languages since the coding for a problem is at the individual instruction level. Okay, so I'm sure this one you don't understand, but you understand more when we do some demonstration concerning machine language and also a bit of assembly languages. Okay, so now each machine has got its own assembly language, which is dependent upon the internal architecture of the processor. Okay, let's make progress. So an assembler is a translator which takes its input in the form of an assembly language program and produces machine language code as its output. Okay, so the high level language, the one we talked about. So the high level language was saying the time and cost of creating machine and assembly languages was quite high. This was motivation to develop high level languages. Since a high level source program must be translated first into a form the machine can understand. So the machine here was simply referring to these machines, which are the computers. Okay, so that they can be able to understand what we are like the high level language. They should be able to translate and be able to understand using their language, which is the zeros and ones machine language. Okay, so this is done by software which is called the compiler. So the compiler is responsible for translating the high level language into machine language so that the computer can understand and be able to do it, to work together like with the user. Okay, so during the process of translation, this is now what happens. Listen to what happens when it is translating the language. So the compiler, it reads the source program's statements, whiles and checks the syntactical errors. Okay, so the high level languages, they offer readability, portability, and easy debug. Okay, let's make progress. Now let's do a summary law of an operating system. Now having looked at the languages, so now let us do now the summary law of an operating system. Okay, so let us take a look at this diagram here. So we are saying an operating system is a system software that manages the general operation of a computer system. So now when you look closely at this picture, it is now showing the general operations of the computer system. So to start with, there's this Windows, so now these the ones in here. Now these are the laws that an operating system plays. Okay, so we are saying it provides security and prevents unauthorized access to a system. How does it do that? For example, if we are able to put a password to our device, meaning if we put the password, no one is able to access our machine minus the credentials, which are the passwords. Okay, so now it also helps the user interact with the computer through a user interface. So from here we will now go to user interfaces. Now we'll be able to understand more. Okay, so now the other law we are saying helping save, organize, find and delete files. So now when you're using an operating system, you are able to save files, organize files, you can name them, give them different names that you can easily remember when you're searching for them. There's also a provision for searching the specific folder or the file in case you've forgotten, and we are also able to delete files because of the operating system. So this is basically a summary of the laws of an operating system. It also manages the input, output, and backing devices, allows users to load, run, and store applications, also resolve errors occurring applications. Okay, so I'm sure this diagram is straight and straightforward. Okay, let's make progress now. We'll look at first now an example GUI operating system. So the three words GUI, which we are pronouncing as GUI, simply stands for graphical user interface. Okay, so the graphical user interface, from the name we can be able to tell that, okay, no, now these are graphics that have got something to do with icons, like graphics. Yeah, for example, so the pictures you're able to see here, they are examples of GUI, which is the graphical user interface operating systems. Okay, so we got also these here, there are also examples. So the GUI or the graphical, they are mostly in form of icons. Yeah. Okay, so now what is now this GUI, the graphical user interface? What is it? So now the GUI, by definition, we're saying is a user interface built around graphics. So here you've seen the first example here. There's windows, areas for displaying information. Okay, so there's also this one, there's list of options or applications users can select from. This is for Windows 7. Okay, and also icons, there are small images used to represent files, folders, or applications. Okay, so now when we talk of the icons, meaning we are simply talking about the files that are identified by the picture. For example, if you look at this diagram here, there's a computer here, there's a cycle bin here, there's also this folder, and also the Windows logo. Yeah, so now icons, they use small images that are used to represent files, folders, and also applications. So by applications, meaning we're simply talking about those softwares, the application softwares that are specifically designed to do some certain task. For example, the VLC, Windows, Google Chrome, after installing, you'll notice that it creates a shortcut on the desktop. So that shortcut that comes in form of a picture, which is called an icon. Okay, also what we call pointers. So the pointers, by the example that we give on the pointers, is the cursor. So the cursor, you can modify them to how you want it to look like. If you want a hand or just a arrow. Okay, so GUIs are quite easy to use due to the visual nature of the interface. Yeah, so you can just click on, and it's very easy to use because the pictures, just the picture of the icon on itself, can be able to say something that, okay, no, this software is used for this software is used for this. So it's easy for the user to easily interact with the computer. Okay, so the user has lots of visual clues as to what things do. Okay. Command line. So apart from the GUI, we also have what we call the command line, which is abbreviated as the CLI. So now the command line, they require the user to enter command prompts to interact with the computer. Okay, so CLI are normally used by expert users as it allows them to, is more complicated to use. So the CLI and is not restricted to a number of predetermined options. Okay. So now if you see this code on the left side here, you can see the black thing. So this black thing, it is the command line interface, which is called the CMD. So now the CMD for this one, it requires experts who knows commands, because once you make a mistake when typing the commands, it will refuse, it won't do anything, it will be actually the errors. It's different from the GUI. The GUI, you are able to see the icons, and which makes it very easy for the user to interact with the computer. Okay, so an example is here on the yellow part. This is now the different types with the command line interfaces that we have. Okay. Yes. Okay. So now, having looked at the definitions and the examples, let us now look at the differences between the two user interfaces. So now, the advantages for GUI, we are saying the user does not need to learn any commands. The interface is easier to use. You can use a pointing device to click and select icons or menu options. So on the advantages part, you can be able to add even your own advantages of this one according to what we've talked about, like the functions and also what it does, the GUI. Okay, let us move on to the disadvantages now. So the disadvantages, were saying takes up more memory than a command line interface. It requires an operating system to operate. Okay, so now to find the differences, we'll be able now, you can just be differentiating. Get the one for the advantage, also differentiate it with the advantage part on the command line interface. So we move on to command line interface now, where we are saying the first advantage, the user has more freedom to use specific command in interacting with the computer. It's different from the GUI, graphical user interface, where the user is just restricted to the options which are there. But with the command line users, they are able to interact with the computer to the fullest, especially the experts. So this one we can also add to say it requires experts, like those who knows commands, for them to be able to easily interact with the computer. So the other advantage you are saying, it is possible to alter computer settings. So meaning this person is using command line interface can easily modify and be able to play around with the settings in the computer system. The disadvantage, we are saying user needs to learn commands. Yeah, commands must be typed in without errors, because once you just make a mistake, meaning the instruction, the computer won't know what you're talking about, meaning you won't be able to interact with the computer that easy. So there are also no visual aids, as you. Okay, so now this brings us to the end of today's lecture. If there are any questions, please you can leave the questions in the comments below, or contact the line which is showing on the screen. And for notes, you can just simply visit the website, which is the ziptech.org, and we'll be able to help you. Okay, so have a good day. This is Mr. Wadia. We wait now for the next lecture, which will be our third lecture, where I'll be talking about the different types, different things under the same operating systems. Okay, so we've done much of the introductory part. Now we'll be digging into details to understand what this operating system, what we're talking about, how we are able to, how we can change, what happens if it crashes. We'll be able to answer all those questions. Okay, and also do some practical educational purposes so that you know how to play around with our operating system. In case it crashes, we'll be able to do one or two things just to make sure that we resolve the issues. Alright, please, thank you for your attention. We can end here for today.